A small island is 2 kilometers offshore in a large lake. The gingerbread man on the island can row his boat 10 kilometers per hour and can run at a speed of 20 kilometers per hour.
If he rows to the closest point to the straight shore, he will land 6 kilometers from a village on the shore. Where should he land to reach the village most quickly by a combination of rowing and running? Time equals distance over velocity, so we want the total distance traveled in the Ginger Man's adventure. The distance traveled will be z and a. But since z and a have different velocities, they will be simply added separately, as shown. The distance z will be divided by the velocity of z. All that will be added by the distance of a divided by the velocity of a.
Now, what is z and a? Z we can find by using a very small idea called the Pythagoras theorem. Since this triangle is a right angle triangle, we can simply say z equals the square root of 2 to the power of 2 plus x to the power of 2. And a is very simple to find, just like Waldo. The total distance minus the stuff we don't need. A equals 6 minus x.
Next, we have to find the derivative.
But why?
Because by finding the derivative, it will give us an equation that we can use to minimize the time and thus giving us the quickest route.
1 over 10 and 1 over 20 are constants, so we're going to derive the square root of 4 plus x squared using the chain rule, and we're going to derive 6 minus x.
So our derivative is 2 times x over 20 times the square root of 4 plus x squared, all minus 1 over 20.
Now all we have to do is
Find Waldo?
simplify our derivative by finding a common denominator of 20 times the square root of 4 plus x squared. Finally, this is our simplified derivative. This derivative is defined everywhere. The denominator will never equal 0. To find the quickest route, we gotta find where the function equals 0.
With a little bit of algebra, we solve for x and we get 2 over root 3.
The quickest route to take is that where you land on the shore 2 over square root of 3 kilometers away from this point.